Types of vaccines and how do they work. Part 2. Types of vaccines were discussed in Part 1. Basically, there are live attenuated vaccines and inactivated vaccines. Pure polysaccharide vaccines, though they are inactivated vaccines, were considered under separate category due to different mechanism of action. Mechanism of action of inactivated vaccines was seen in Part 1. This part is about live attenuated and pure polysaccharide vaccines. Live viral vaccines examples include measles, mumps, rubella, varicella vaccine. Live bacteria example is BCG. Let's say about live viral vaccines. From the site of injection, viral particles replicate and disseminate throughout the vascular network. And then they activate dendritic cells at multiple sites. This is in contrast to inactivated vaccines where dendritic cells are activated at the site of injection. So in inactivated vaccines, site of injection is very important, but here site and route are of minor importance. So live vaccines are given by various routes like subcutaneous, oral example oral polio vaccine, nasal example live influenza vaccine. And then dendritic cells migrate to the corresponding lymph nodes. So there is multifocal lymph node activation. This may cause immunological interference between two live vaccines. So two live vaccines are given usually 4 weeks apart or on the same day to avoid immunological interference, with few exceptions. Inside the lymph node, mechanism of action is similar to other inactivated vaccines. That is, follicular T helper cells are activated and then they activate B cells, and the B cells differentiate into memory B cells and plasma cells. And the plasma cells produce antibodies. In addition to this, in live viral vaccines, there is also CD8, that is cytotoxic T cell response. Live bacterial vaccine, that is BCG, T cells are the main effectors. In contrast to inactivated vaccines, there is replication of organisms in live vaccines. There are clinical implications. First one is they can be markedly neutralized by maternal antibodies. These maternal antibodies usually wane by 6 to 9 months of age. So live viral vaccines like measles, mumps, rubella or varicella vaccines are usually given after 6 to 9 months of age. Some exceptions are BCG. Here maternal antibodies may actually enhance the T cell response. So this can be given at birth. Another one is oral polio vaccine. Here there are no maternal IgA antibodies in the infant's gut to neutralize the virus present in the vaccine. And the replication causes constant source of antigen. This persistent exposure to antigen causes natural boosting. So boosters are usually not needed. And the replication, because of this replication, they cannot be given in the immunocompromised because they can cause actual disease. One example is measles, mumps, rubella vaccine. Here it is given at 9 months due to maternal antibodies, and it is given as subcutaneous injection. The second dose is given because uptake of vaccine is not 100%. That is, with the first dose, that is adequate response is not attained with first dose in some children. This is known as primary vaccine failure. And not for secondary vaccine failure, that is waning of antibodies with time. Let's say pure polysaccharide vaccines. Here, from the site of injection, the antigen, without the help of dendritic cells, reaches marginal zone of spleen and lymph node. This marginal zone is not adequately developed in under 2 years of age. So, pure polysaccharide vaccines are usually given after 2 years. And then inside the lymph node, B cells are activated without involvement of T cells, and plasma cells, they differentiate into plasma cells and antibodies are produced. So these pure polysaccharide vaccines are T cell independent, so no germinal center reaction, so no memory B cells, so no immune memory, so no booster response. Repeat doses are not boosters but revaccinations. Example is typhoid VA capsular polysaccharide vaccine. If given, IAP recommends first dose at 2 years and then repeat doses are given once in 3 years. These doses are not booster doses but only revaccinations. In some pure polysaccharide vaccines like group C meningococcal vaccine, there is hyporesponsiveness. That is, revaccinations may induce lower immune response than the first dose. Live vaccines, inactivated vaccines other than pure polysaccharides, and pure polysaccharide vaccines. Immune memory due to involvement of T cells, it is present in live vaccines and other inactivated vaccines but absent in pure polysaccharide vaccines. Boosters are usually not needed for live vaccines due to natural boosting, are usually given for inactivated vaccines. But in pure polysaccharide vaccines, they are not boosters but only revaccinations. Hyporesponsiveness is not there in live vaccines or other inactivated vaccines, but it's there in some pure polysaccharide vaccines. So, generally speaking, live vaccines, with exceptions of BCG and oral polio vaccines, are considered superior to inactivated vaccines other than pure polysaccharides, which are in turn superior to pure polysaccharide vaccines.